Class, welcome back. This is 8.4. The second objective here is we want to solve rational inequalities. Well, what is a rational inequality? Well, it will be some kind of a fraction with an inequality and perhaps another fraction or just a constant or a number or zero. Doesn't matter, but in there somewhere, rational means that we will have a fraction. So let's review a couple of important facts. That if we have 0 and we divide it by anything, that'll still be 0. But if I have anything and I try to divide it by 0, that's undefined. I can't do that. So if we look over here at the steps for solving our inequalities, the reason why we're going to solve all the values that make the denominator 0 is we want to make sure that we don't create an undefined expression while we are solving. Then we're going to solve the equation as we're going to treat it like an equal to. Okay, and then we're going to label our critical points on the number line just like we did last time. Then we're going to choose test points for each region. So what does this look like? Well, if I have 7 over x plus 2 is less than 4. First of all, I'm going to say, wait a minute, I got to make sure that the denominator is not 0 here because that's a problem. So if x was negative 2, then this denominator would be 0. So we're going to just write over here, we know that x cannot be negative 2. This is a critical point that we'll get to in just a minute. Now I'm going to solve this equation as is and just pretend like this says equal to. So to get rid of the x plus 2, I'm going to multiply both sides by x plus 2 because that will cancel here, top to bottom, and then I'll need to distribute here. So what I have, again, I'm just going to treat this like it's equal to. I'm going to have that 7 is equal to 4x plus 8. Okay, fantastic. So keep solving here. We've got negative 8, so negative 1 is equal to 4x. Divide by 4, and x is equal to negative 1/4. So this is another value. Okay, these now are all my critical points. Okay, so the critical points are going to divide up our number line. So what does this number line look like? Well, I've got 0, 1, negative 1, and negative 2. Do negative 3 over here and a positive 1. But we need to have this negative 1/4. So critical points are negative 2. So I'm going to say this matters and negative 1/4. All right, so this divides our number line into the region from negative infinity all the way to negative 2. But again, we know that negative 2 can't be included, so no matter what, that's going to have a parenthesis. Anytime you find the value that the denominator can't be, you obviously can't include it, or it would make the denominator 0. Okay, then we have this region of negative 2 to negative 1/4, and then from 1/4 on. So I'm going to start by plugging in 0 because it is the easiest. So when I plug in 0 into the original equation, I get that 7 over 0 plus 2 is less than 4. Well, 7 over 0 plus 2, so 7/2 is 3.5 is less than 4. Well, this is a true statement. 3.5 is less than 4. So this is going to be a true region. All right, now I'm going to plug in negative 1 because it's in the middle there. So I'm going to get 7, and I've got negative 1 plus 2 is less than 4. That means that 7 over 1 is less than 4, so 7 is less than 4. This is obviously false, 7's bigger. So the region in the middle of here, when I plugged in negative 1, or the value here of negative 1 that I used as my test point, this gives us a false result. Okay, well, let's just check this one because it's not necessarily true that it's going to follow every other pattern. So for now, we want to just plug in test points for every single region. So now I'm going to plug in this test point of negative 3. So I'm just writing the test points in red so we can see what we're plugging in. 7 over negative 3 plus 2 is greater than 4. Well, that's 7 over negative 1, which is just a negative 7. So negative 7 is less than 4. Well, that is also true. All right, so what then does this solution look like? Well, I'm going to include everything graphically, right, from negative infinity to 2, but it's not going to include 2. Again, we can't have negative 2 as a solution or the denominator would be 0. It's also going to include everything from negative 1/2 to a positive infinity. All right, so this means I'm going to have to union here. So I'm going to go from negative infinity to -2, not including it, union with parenthesis, -1/4 to a positive infinity. Now, why is this one right here a parenthesis? It's a parenthesis because this is just less than. There's no equal to part of the statement. It's a parenthesis for a different reason than this. This one is a parenthesis because x cannot equal -2. Okay, infinities always have parentheses. All right, so that is one example. I want to work through 3 more and do a real quick reminder that, again, if we have, if we have a greater than or less than, then we're going to have parentheses. And if we have brackets, no, geez. If we have greater than, equal to, or less than equal to, if there's an equal to part, then this is going to be a bracket. And of course, infinities are also going to be parentheses. So just want to remember that. Also, always plug back into your original, then you don't have to worry about flipping signs or anything else that comes along with inequalities. Okay, so next problem. Let's look at x minus 5 over x minus 6, and that's going to be greater than 0. All right, my first step is I got to make sure that whatever I do, I don't make this denominator 0. So I'm going to look here and say, hey, if x was 6, 6 minus 6 would make this denominator 0. Can't have that. So I know that x cannot be the value of 6. This is my first critical point. All right, now I'm going to solve this inequality. Well, when I go to solve it, again, I'm going to multiply both sides by the denominator. This isn't very helpful. I mean, it is, because anything times 0 is 0, so that's great. So really, all I have is that x minus 5 is greater than 0. This is still 0 over here. That makes it pretty easy. So I'm going to add 5 to both sides, and I get that x is greater than 5. All right, so 5 is my other critical point. So I'm just going to write 5 over here. So these are my 2 critical points again. And now I am going to use both of these critical points and label the critical points on the number line. Again, I'm going to label all of the critical points. That includes anything that would make the denominator 0 and anything that is a solution to an equation, to the equation. So on my label, I'm going to have 6 and 5. So let's do 0, 1, 2, 3, 4, 5, 6. So critical point of 5 and critical point of 6. Okay, well, this is kind of weird, but again, this divides our regions from negative infinity all the way to 5, 5 to 6, and 6 to a positive infinity. All right, well, easiest thing to plug in is 0, so I'm going to plug in 0 into the original equation. Again, this is super important that you always plug it into the original so that you don't mess with signs or outcomes. So if x were 0, I would get -5 over -6, which actually turns out to be 5 over 6, is greater than 0. Well, this is positive, so anything positive is greater than 0, so this is true. Now again, this came from 0 came from this region here. So any number that comes from this region here is going to be true. All right, let's go between 5 and 6. Boo-hoo. I'm going to have to use a fraction. So I'm just going to say, or a decimal, I'm going to use 5.5 minus 5 over 5.5 minus 6. Well, 5.5 minus 5 is going to give me a 0.5 over a negative 0.5, which is going to give me a -1. So I get that -1 is greater than 0. This is false. Negatives are always less than 0. All right, so in between here, this little dinky space in here is false. All right, now I'm going to plug in the value 7 as another test point. So we have 7 minus 5 over 7 minus 6. That's going to be 2 over 1, or the value of 2. 2 is greater than 0. That is absolutely true. So we've got a true point over here as well. All right, so now that we've decided everywhere true, we're going to include, so again, all of this here, all the way to negative infinity is going to be included. Anything that you plug in, all the way to like negative 1 million, negative trillion, whatever, is going to be included. But 5 itself will not be included. The reason why 5 itself will not be included is because this is not an equal to statement. Okay, so we're not going to include 5. 6 is not going to be included, but that's because the value of 6 itself would make this denominator 0. So we cannot include 6. All right, so this is going to be everything from 6 to infinity. So writing this in interval notation, then we would have negative infinity to 5, not including 5, union with 6, not including 6, all the way to positive infinity. Okay, so this is the graphical solution. This is the interval notation solution. Let's do a couple more of these and see. Ah, dang it, I shouldn't have erased that. Well, you can look at it from before. It gives me more room anyway. All right, so let's do x plus 1 over x minus 4 is greater than or equal to 0 now. Okay, remember that my first step is always going to be, hey, I cannot have this be 0. So the value of 4 would make this denominator 0. I cannot have an undefined denominator. So we know that x cannot be equal to 4. Super important. This is my first critical point. Now I'm going to solve this equation by multiplying both sides by this x minus 4, because I need to get rid of this denominator. Same thing's going to happen here that happened last time. I'm just going to have x plus 1 is going to be greater than or equal to 0, because 0 times anything is 0. So really the next critical point, and again I can solve this as if it's equal to, is going to be negative 1. So we'll put this critical point up here. So now that we've identified both of our critical points, then we want to put all of them on the number line. So we've got negative 1. Okay, so I'm going to draw my lines in the sand here. We don't want, we're talking about negative 1 and a positive 4. So I've got the region from negative infinity to negative 1, from negative 1 to 4, and from 4 to positive infinity. Those are the 3 regions. I got a test. So again, always going to plug in 0 because it's piece cake. So let's use 0 right here as our test point. And we'll say if x is 0, then here we're going to get a negative 1/4 is greater than 0. Well, a negative is never bigger than 0, so this is false. That means that this region of the graph is also false. And now I'm going to use the test point negative 2. If we've got negative 2 plus 1 over negative 2 minus 4 is greater than or equal to 0, well, that's going to be a negative 1 over negative 6, which is going to end up being positive 1/6. 1/6 is greater than or equal to 0. This is definitely a true statement. So we've got true here. Now I'm going to plug in the value 5. Let's try the value 5. All right, so we've got 5 plus 1 over 5 minus 4 is greater than or equal to 0. Well, that's 6 over 1, and 6 is definitely greater than or equal to 0. So this is, again, true. So we're talking about all the values from negative infinity to negative 1. But is the value negative 1 included? Well, how can I tell? I'm going to go back to here and say, hey, this is equal to. So that means this value right here will be included. I am going to include negative 1. All right, I'm not going to include any of these values, but the value of 4 is going to have a parenthesis, not a bracket. Even though this says equal to, we're putting a parenthesis here because this, we can't have that value of -4. If I plug in -4 in here, then the denominator will be 0. So although -4 is a critical point and a dividing line, we can't have the point of 4 itself. So we're going to say that we have everything 4 or greater, but not including 4. So really important to notice that these signs aren't always going to be brackets just because this is equal to. Now it will always be when you're solving the solution. The stuff from step 2 will always have a bracket if there's an equal to. But this parenthesis will always have to be where the critical point of what you cannot have. So